what I was telling is that this
Hmm.
is a drum, right? Horizontal drum, right?
Hmm.
Okay. And let us say that we have a hole here like this. We have a hole. Okay. And
Hmm.
here, through this hole, I am just pouring water. I am pouring water. Okay.
Okay.
I am I am pouring water with a flow rate of Q, let us say. Okay. And in another
Hmm.
case, for another case, I have another case. Okay. In that case, I have a drum like this. Okay. Drum like this. And similarly, I have a hole here and I am just pouring water with a flow rate of Q. Okay. So both of these drums are having same length and diameter. Okay. Same length and diameter.
Hmm.
Okay. So this length is L,
Okay.
that is equal to the diameter. And this is also D. This is also D. This is also D. Okay. And I tell this as my case 1 and this as my case 2. So for the case 2, you have to draw, firstly, you have to draw this height. If I take this as my height of the water level, you have to draw the age versus time curve. Age versus time curve for this case 2.
Okay. For case 2, area is
Yes,
constant. Discharge is constant, right?
discharge is constant.
And H versus time graph.
Age versus time graph you have to draw, right?
Q by A into T. So it's like at T is equal to 0, height will be 0. Shall I
You
consider
have to
that?
draw it. First, you have to draw it and
Okay.
show me. Yes, at t equal to 0, there is no water, right?
It's simple linear. Dikra?
Simple linear. Okay, okay. Now, on the same graph, okay,
Hmm.
on the same HT plane, you draw the same graph for this case 1.
Case 1.
Hmm.
So A will be varying. Q is constant. A will be varying. Okay. A variation will be increasing, decreasing. So H तो increasing. Hmm. Increase हो रहा होगा. Initially height तेजी से बढ़े. R.
Take your
Okay.
time and draw the graph.
A का वेरिएशन कैसा हो रहा है? Which is equal to Q by T. Okay. T. एरिया ज्यादा इंक्रीज हो रहा है. It will be non-linear, but
Hmm.
area is varying. तो hmm,
Okay. Uh, okay.
नॉन लीनियर
Leave
वेरिएशन होगा
it.
बट ओके
हाँ, नॉन लीनियर वेरिएशन
दैट्स
होगा,
इट
लेकिन
बट
क्यों होगा? नॉन लीनियर
हाँ
वेरिएशन क्यों होगा?
क्योंकि जो भी एक कांस्टेंट नहीं है वाइल फिलिंग
क्या कांस्टेंट नहीं है?
तो
एरिया।
इसीलिए
एरिया।
एरिया
कौन
ऑन
सा
विच
एरिया?
वाटर इज बीइंग
एरिया ऑन विच द वाटर इज बीइंग
rested like
रेस्टेड। ओके, 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 ओके।
where water is getting
ओके,
settled area is not being
ओके। सो
constant
कैन यू?
तो फिर
ओके, ओके, ओके,
एच बी नॉन
ओके। सो
लीनियरली वेरी होगा
okay, okay. So can you just draw the variation of area with time? Variation of area of this.
वेरिएशन ऑफ
Yes, variation of area
एरिया विथ
on on which the water will be rested, as you said. So can you variation of that
हाँ
area
एरिया विथ
time? Show me.
like area with time
Hmm.
like something like this दिख रहा है
So area is increasing and then it will decrease. Right, right. Very good. So now you tell me that when you are uh, I mean, when you are thinking that how the height will vary, how you are thinking?
yeah.
I mean, why this area will influence the height? Why?
बिकॉज जो भी वॉल्यूम डिस्चार्ज हो रहा है
Hmm.
वॉल्यूम तो कांस्टेंट जो भी डिस्चार्ज हो रहा है वो तो कांस्टेंट है लेकिन जो भी वॉल्यूम जो भी डिफरेंशियल वॉल्यूम है
Hmm.
वो भी सेम है एवरी मोमेंट
वो भी सेम
बट
है।
एज दिस डिफरेंशियल वॉल्यूम जो भी फिल हो रहा है वो सेम है
अच्छा।
लेकिन
Write the
एज
equation.
एरिया इज
Write the equation for Q, H, and A. Write the equation for Q,
क्यू
H, and H and A.
क्यू डी क्यू इज इक्वल टू डी इंटू ए एच एंड क्यू इज इक्वल टू एरिया दैट डिफरेंशियल एरिया
Hmm.
जो भी
Hmm.
है
Hmm.
एट दैट मोमेंट इनटू जो भी हाइट इन्फ्लुएंस हो रहा है जो भी हाइट ऐड हो रहा है
जो भी हाइट ऐड हो रहा है।
क्यू इज
So
इक्वल टू
Q is what? Q is volumetric flow rate, right?
यस क्यू इज इक्वल टू एरिया इंटू एच ए एच
But Q has
ओके
a per unit time unit also.
क्यू इंटू टी इज इक्वल टू डी इंटू ए एच and where h is the amount of like change in height q into t is
Okay.
equal to a into h
You
and
tell me the equation that you have written. Q, I will just
q
write here.
into 2 is equal to a into h where h is the change in height
A into H. This one,
uh, h
right?
is change into height change in height
Change in height. Okay.
and
So if I consider that H not equal to zero, that is initial height equal to zero, then it is H, right?
hmm,
Okay.
yes
Okay. Okay. But this is a finite time. For each and every instant, will it be changed or not? This area, for each and every instant,
uh,
this area will change or not?
yes change
So,
it will change
so for infinitesimal time, can you write it?
hmm.
For example,
dh is
I
equal
write,
to
yes, yes, yes.
dh is
Tell me,
equal
tell me. DH equal to
dh is equal to q into dt by a में
Q into dt by A.
a
Right. Good. Very good. So now from this equation only, now you have drawn an draw. you have drawn this area versus time graph like this, right?
Yes.
Okay. So
Okay. DH
now,
by.
now you
Hmm.
see that you have an expression for dH is equal to Q by AT, and you know
Hmm.
that how this A will vary. I mean, intuitively you know. So now from this
Yes.
equation, I mean, will you try to draw this HT graph from this equation?
Okay. DH by dt will be like this. As A is increasing.
Hmm.
Okay. DH by dt will be like this. So slope is first. Uh, slope is first. Decrease. Increasing slope. It's like increasing slope. Slope is increasing. So it will
Hmm.
be like a uh, convex down, convex. What?
So you are drawing what? H versus T or H dash versus T?
H versus T.
Show me, show me. Okay, 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 leave it. Okay. So now we will do some thermodynamics. Okay. So,
Okay.
okay, we will do some thermodynamics here. If I have a beaker, okay, I am having a beaker in which I have some water. Okay. So this water is at minus, so water cannot be at something minus. So I have ice at first. I have ice. So ice at minus 10 degrees Celsius. Okay. And
Hmm.
this is open to atmosphere. This is open to atmosphere. And now
Okay.
you are heating it. You are heating it, right? So
Yes.
now first draw the variation of temperature with time.
With time.
Hmm.
minus 10 degrees Celsius. तो जो
And
भी
show me.
है like
Yeah.
0 degrees Celsius.
Yeah. Yeah. Show me. Minus 10, minus 10. So temperature versus time. So at first, at time t equal to 0, it was minus 10. So why have you started this?
Ah,
Uh,
yes, yes. Okay. Hmm. T, T.
Show me. Okay. It is 0. And then
Hmm.
after that, it is increasing. So, I mean, is it so okay, so I'm telling that my time varies from t equal to 0 to t equal to, let us say, 1 hour. 1 hour. Now you draw. So you have to
Okay.
draw it like this, that it is t equal to 0 and this is t equal to 3600 seconds. And now you have to draw it.
Okay.
Draw.
Okay.
Yeah. Draw it.
Heat U is equal to C T1 T Two minus 52. Then after here, temperature versus ah
Hmm.
300. Okay, after 1 hour, what will be the temperature?
Hmm.
ओके बट इसके लिए तो ऑलमोस्ट अगर 1 आवर के बाद टेम्परेचर चाहिए है हम्म,
So you think it like this.
कितना
You
कितना हीट
you just huh, you just forget about any mathematics. Okay, you just forget about any mathematics and you think like it that in your home in a pan you are heating up an ice, a chunk of an ice. You think it like this. Now you draw. I mean, for the moment, you just forget about any mathematics and you draw by your common sense and your daily experience. That if you heat a chunk of ice, okay, so for your example, I am CCC. I am just
ओके
telling you that this ice has a mass of, let us say, 100 grams. Okay, this ice is having a mass of 100 gram. Now, from your,
ओके
I mean, common sense, you just draw it. What do
ओके
you
इट
think?
विल टर्न इट इनटू लाइक स्टीम हो जाएगा इट विल कन्वर्ट इनटू
Show me the graph.
100 डिग्रीज माइनस 10 डिग्रीज दिख रहा है
हाँ अब दिख रहा है, अब दिख रहा है. ओके, minus 10, 0, then constant, then 100. Okay, okay. So those inclined lines are the straight lines or curved lines? Those are straight or curved?
दे विल बी स्ट्राइट
They will be straight.
यस
Why? Why? Those inclined lines,
बिकॉज
like you have drawn it like this, right? So those,
जो भी
so I am talking about these lines. So will they be straight or
हाँ
curved?
yeah they will be straight but each line their slope will be different like after
Okay, so
like
why
melting
they will be
and
straight first
vaporization
of all? Why they will be
हाँ
straight?
yes it will be straight like if the
Why?
heat rate
Why?
जो भी हम दे रहा है as we are giving same heat rate and जो भी
Hmm.
and mass and जो भी specific heat जो भी चाहिए वो भी constant है तो as heat rate mass and specific heat is constant so
So
that's why
specific
the
heat,
slope will
see, I have only provided you the data that the heat rate is constant. That is fine. And the,
okay
okay, that is fine. Okay.
okay
But I have not talked anything about mass. I have not talked anything about the specific heat. So just don't assume anything by yourself. Just you see
okay
this scenario. You see this scenario. This is an open beaker. This is an
okay
open
okay
beaker. Okay, open beaker. The
Hmm.
above is open. Okay.
if
Okay.
specific heat is varying and अगर वो भी वेरी कर रहा है तो ये थोड़ा नॉन
Not
लीनियर
if.
जाएगा
Not if. I mean, what do you know about the specific heat? Is it a function of temperature or not? What do you know about
yeah
it?
it is a function of temperature
And how it varies?
it
For
varies non
water, for
linearly
no, no, no. So with temperature, will the specific heat decrease or increase? How it varies?
for ice and water
Hmm? For ice and water?
for ice and water it remains same like
Remain same. Okay. And for vapor?
for vapor, like agar it may vary if it is not perfect if it is not considered as an perfect gas, then it will vary, like specific heat will
What you
vary.
will consider here? What you will consider here? I am asking that.
As इनिशियली अगर जो भी है वे कम प्रेशर में रहता है, हमारा जो
Hmm.
भी अगर नॉर्मल कंडीशंस में जो भी अब वेपर फॉर्म हो रहा है, it will be at less pressure only, so we can consider it as an ideal gas, like, so we can
Acha.
consider it as uh, constant specific heat
Constant specific heat. Okay.
for vapor too.
Okay. Okay. Can you draw the mass versus time graph? Mass versus time. Mass
Okay,
that is
mass
inside the
versus.
beaker. Mass that is
Hmm.
inside the beaker versus time.
Hmm. Okay. होता जाएगा as T is very cheap
Show me.
as temperature T increase or other will also. I am considering it as like अगर C specific heat constant है तो in normal
Hmm.
vapor gas,
Hmm.
then जो भी है mass up to 100 डिग्री सेल्सियस रीच होगा,
Hmm.
मास तो कांस्टेंट रहेगा।
Hmm.
उसके
फिर क्या
बाद
होगा?
मास मास उसके बाद डिक्रीज होना चालू होगा,
Hmm.
and it will very linearly if we consider
Hmm.
linearly. This is changing, temperature is changing, this is not a constant term, तो नॉन लीनियर वेरिएशन होगा।
कैसा कैसा नॉन लीनियर मतलब कैसा? No, I could not understand. Okay, so first of all, you have drawn it like this. That is, if this is mass and this is time, so mass inside the beaker is constant. Now it is decreasing. So I am just giving you three options, like this, or like this. That is linear. So if I name it 1, 2, 3, you tell me that out of 1, 2, 3, which is correct and which is wrong and why. And also you tell me that at this point, what is the temperature at this point?
At
This
that
T
point
star,
100 uh,
what is the temperature? So T at
like
T star.
slightly greater than 100 degrees Celsius.
Okay. So let us say 105. Okay. Okay. Now you draw. I mean, now you tell me that will it be
This
1, will
T,
it be 2, or will it be 3? Tell me.
the slope will be decreasing. Uh, the slope will be decreasing. Will be having a decreasing slope, so it will
That
be
means 1, 2,
3,
or 3. It will be 3.
3, 3, 3.
Okay, it will be 3. And why? You are saying
क्योंकि
that this dmdt is decreasing. Okay. Why?
as जो भी as temperature increasing,
Hmm.
जो भी इक्वेशन बनाया था क्यू जो भी
Which equation?
हीट
You
हीट
tell me
रेट
the equation. You tell me the
हीट
equation.
रेट इनटू
Heat rate into q dot into
हीट रेट इनटू टाइम इज इक्वल टू
hmm,
mass of the vapor that is being created
hmm, mass of vapor.
into T minus 100.
Okay,
No,
leave it, leave
that's
it.
something,
See, now
something
I
else.
will ask you the last question from strength of material. Okay,
Okay.
draw the stress strain diagram for aluminium.
The strain diagram of aluminum.
Mhm.
No real strength occurs.
Draw the stress strain diagram on the same curve for cast iron.
Cast iron.
Yeah, show me. Now draw for the mild steel.
Mild steel. Oh,
Okay, okay. So Krishna, your interview is over. Now let me give you
hmm,
the feedback. I will start with the strength of materials. So you have drawn it something like this. Stress strain. Aluminium, you have drawn something like this. Cast iron is this, and mild steel, you have drawn something like this, right? So first of all,
hmm,
you have drawn the natures correctly, but the slopes are not correct. Okay, you go back and see that how the Young's modulus will vary with this variation of the material. Cast iron is a very strong material. Okay, so will the slope
but
of this cast iron, will it be lesser than aluminium or not? That you have to see. Cast iron is a very strong
okay.
material. Okay, so these
Hmm,
natures are correct, but this variational nature of the slope, like this line,
hmm,
I mean, will it be here or here or here? That you have to see. Okay, so this
okay.
you have not drawn correctly. So in strength of materials, this stress strain diagram is their one of the favorite topics. Okay, and
Okay.
not only the stress strain diagram of the mild steel, but also other engineering materials like rubber, like cast iron, like aluminium. At least these three, that is the cast iron, aluminium, and mild steel, right? And everything,
Hmm,
that is why this thing happened and why this thing happened, everything you have to understand. like 100% about the stress strain diagram. Okay, you have to understand it for the interview. Okay, now you see these type of questions are their favorite questions. That is the drawing graphs. In thermodynamics, they can ask you mostly two types of questions, two or three types of questions. One is like this, that is, you have water. Either they will ask something from water, that is, if there is a pipe and the actually the water is flowing, then how the temperature will vary, or like this. Okay. Otherwise, they can also ask you from a piston cylinder type arrangement. Clear? Now you see that what you have done in this question, you have drawn this t versus time curve again almost correctly, but you have to be very careful about the slopes of these curves, the slopes of this curve, because you see they are very particular about these things. They are making you draw the graphs. Okay, so in the graphs, the slope is the most important thing. Slope of the curve is the most important thing for a graph. So you have to be very careful about the slope. And while you are drawing this graph, you ask them as many questions as you can. Like, for example, you are making a mistake of assuming things. That is, if the CP is constant or not, if that is constant or not. So when you will tell them that, sir, if the CP is constant, then they will ask you directly that, what do you think for this scenario? Will the CP be constant or not? Okay, so you have told it correctly that for for ice and water, the CP is almost constant, not exactly constant, almost constant. But this vapor, this CP will vary. Now go back to your thermodynamics and see that how this CP will vary. Will it decrease with temperature or will it increase with temperature? And this part, that is, after it reaches the 100 degrees Celsius, if I write the heat balance equation, that is Q into dt is equal to m dot water into, or yes, no, m water, not m dot, m water into Cp vapor into, sorry, m dot vapor into Cp vapor, right, into what? Dt. This will be my equation, right? So dt is not, so dt. Okay, so here you see that this m is also changing, this Cp is also changing. So according to that, you have to draw
Yes.
your graph dt dt. That is your slope. That is the slope of this graph. That will change accordingly. This is constant, but this is also changing. This is also changing. So you have to take all these things into consideration. Okay, this is how you think like an engineer. Okay, so, and for this also, yes, you have told it almost correctly that this will be constant. After that, there will be a non-linear variation. Okay, now I don't know that how you just said that this will be decreasing, but again, this same equation will be applicable there also, right? So
Okay.
from this equation only, you have to see this variation of Cp. Then only you can say if this will decrease, increase, or stay constant. So just go through your thermodynamics and just see about the variation of Cp also. Okay, and while drawing these type of curves, be very sure to ask them about the assumption. Okay, and finally, this fluid mechanics, everything was correct, but the graph will be something like this. So this is the constant, and this graph will be something like this. Okay, you are almost correct.
Okay.
That is the variation of these things. Okay, so but
Okay.
I mean, the thought the thought process for the fluid mechanics that you had, that was almost good. Okay, that was I mean
Mm,
almost good. But the thing is that they will not give these much hints. They will give hints,
o-
but they may not give these much hints that I have given. Okay, so that
Okay.
was about the feedback of the interview. Now the meeting will end almost in 1 minute. Okay, so there will be a
Mm,
feedback link.
o-
Please give me some feedback as much, I mean, as you felt. If you, okay, so that
Okay.
was the thing. So prepare well, and most probably within a week or so, we can meet for another interview if you want to see your
Mm,
progress. Okay. Okay.
Okay. Hmm.
Okay. Okay,
Okay.
then all the best.
Hmm.
Okay, it was a pleasure
Thank you.
to meet you again,
Yeah.
and all the best.
This was like good. अच्छा लगा था ये interview.
Good, very good. I know that you will improve and you will do good in BARC. So improve and we will meet once again for this to judge your improvement.
Okay.
Okay? Okay.
Okay.
These questions are the exact questions, like only these type of questions will be will be asked